Now we're going to look at another example where things don't work out quite as pretty with this polynomial, this cubic 4-term polynomial. You could, again, try to look for grouping, but this one is not going to group. The like terms here are not going to produce a common binomial factor. But thankfully, we're told a linear factor of x plus 10 is provided for us. Now, what that's helping us do is know that there's one x-intercept that I can help divide with synthetic division or long division on this polynomial and keep going. So we want to go ahead and run through synthetic division since this is linear. So we say x plus 10 is equal to 0. We subtract 10 from both sides to get our number in the box. X equals negative 10. So we get a little half box thingy, whatever that's about, just to keep it separated from the rest of the coefficients. So my coefficients for x to the third plus 8x squared minus 18x plus 20. Bring the coefficients down. We've got the 1 here, that's in front. We've got the 8 coming down, the negative 18 coming down, and the 20 coming down. Give yourself a little math space for a math bar. The math space is for our numbers. The first one, of course, comes down, 1. And then we're always multiplying this way to that number in the box and then putting the result over here. So we've got negative 10. 1 times negative 10 is negative 10. We add vertically with the number above it, and that gives us a negative 2. And then we repeat the process. Negative 2 times negative 10 should give us a positive 20 underneath the next one. And then we add there, get 2, positive 2, and then repeat. So we're going to go to all the way over here to the negative 10, and that's going to give us a negative 20. And as expected, we get a result of 0. It's expected because we were told that x plus 10 is a factor, so the remainder better be 0 on that negative 10 when we use negative 10 for synthetic division. Because if x plus 10 is a factor, then it means that f of negative 10 had to be 0, which is the remainder theorem. Anyway, all that to say, we have now factored one layer of this cubic function. We now have a quadratic because it was a cubic divided by a linear. We now have a quadratic first term, so that's x squared. And then descending order, x to the 1, x to the none. We can write x plus 10 times this quadratic, x squared minus 2x plus 2, is equal to our original function f of x. So this polynomial, this cubic, is now a set of 2 by 3 factors. And what we can do is continue to try to factor. And so we're going to go ahead and say, all right, let's try out the magic x. So we throw out a magic x trying to help ourselves out and have a short way through it. So we put 2 up top, negative 2 on the bottom, and then we think through our magic numbers, and we're like, we only have 2 and 1, and there's no way to make 2 and 1 make 2. Bummer. So what does that mean? It means we run to the quadratic formula. The quadratic formula requires us to know the a, b, and c values of our quadratic. This is our a term, which is a 1, our b term, which is a negative 2, and our c term, which is a 2. So we set up the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We replace each term, each letter appropriately, so it's going to be negative parentheses negative 2 plus or minus the square root of negative 2 squared minus 4 times a times c all over 2a. And then we reduce as much as possible. So our negative 2 is plus 2. And then we get in here, this is negative 2 squared. That's going to turn into a positive 4 minus, and then it's 4 times 1 times 2 all together. So 4 times 2 is 8. So it's really 4 minus 8. So let's rewrite the top. This is positive 2 plus or minus the square root of 4 minus 8 is negative 4 all over 2. Well, we are looking for all solutions, and we are going to be finding some imaginary ones here because we have a negative 4. We're supposed to pull out an I and then consider the square root of 4. So this plus or minus square root of negative 4 is actually a plus or minus 2i, because the square root of 4 is 2. So we rewrite this to be 2 plus or minus 2i, all over 2. Then we simplify this problem. It's a triangle problem where all three of these numbers have a common factor, so you divide them all, you reduce them all by a factor of 2, and we should get 1 plus or minus 1i over 1, which you don't have to write. Now, if you don't like that triangle simplification, you can break it up to be 2 over 2 plus or minus 2i over 2 and get the same result. 2 divided by 2 is 1, and so in both instances, you would still get the 1, and then 2 divided by 2 here gives you just the I. So 1 plus or minus I is 2 answers. So my zeros of this algebraically, although I don't know if you would want to call your imaginary ones zeros, they're roots or they're solutions, if you will. Anyway, so my three solutions, I've got x equals negative 10, which I guess I didn't actually set this equal to 0 to solve that. So x plus 10 equals 0, and then you would get x equals negative 10 as one answer. And then this quadratic, when it was set equal to 0, I had to use the quadratic formula, and that produced my other two answers, which are 1 plus I, comma, 1 minus I. Now there are three solutions, which there are supposed to be three solutions because I had a cubic function. I had, and when I say three solutions, they're three complex solutions. I have one real solution, and then I have two complex solutions, two imaginary solutions, which satisfies the rational root theorem.